Dear student, in this session we will discuss subtopic 4.1 scheduling types from unit number 4 CPU scheduling and algorithms. The course outcome is you will able to apply the scheduling algorithms to calculate the turnaround time and the average waiting time. The learning outcome is you will able to justify the need and objectives of job scheduling with some relevant examples. Content we are going to cover in unit number 4 is that is CPU scheduling and algorithms are scheduling type, within scheduling types, the objectives of scheduling, CPU and IO burst cycles, preemptive non-preemptive scheduling and the scheduling criteria. The objectives of scheduling. Now we know that the objective of multiprogramming is to have some processes running all the times in order to maximize the CPU utilization. Thus, several processes are kept into the memory at the same time. So when one process waits, the operating system takes the CPU away from that particular process and gives CPU to some another process for execution. So while doing this, one resource or primary resource we required is the CPU. Thus, this scheduling of CPU is central to the operating system design. Thus, the objectives are we'll able to discuss the criteria for selecting the CPU algorithm and describe various CPU scheduling algorithms. Let us see the CPU and IO burst cycle. In order to maximize the CPU utilization, the multi-programming we execute. The process's execution consists of a cycle of CPU execution and the IO wait, which is also called as CPU and IO burst cycle. That means whenever the process begins its execution, it begins with the CPU burst cycle, which is followed by the IO burst, which is again followed by some another CPU burst, and so on. This particular cycle will continue until the CPU burst ends with a system which requests to terminate the execution. An IO bound programs has many short CPU bursts. So whenever the program is related to IO related activities, then the CPU burst is short. Whenever the program are related to CPU bound, then a long CPU burst might be there. So this distribution can be an important while selection of the appropriate CPU scheduling algorithms. So let us discuss the preemptive and non-preemptive scheduling. Now short-term schedulers, they select the processes which are available in the ready queue and allocates the CPU to one of them for execution. The queues may be ordered in various ways. It may be in first come first serve, FIFO, priority, trees or under unordered linked list and so on. So CPU scheduling decision may take place when a process switches from running state to waiting state, when a process switches from running state to ready state, when a process switches from waiting state to ready state, or when a process terminates. So scheduling under situation 1 and 4 is a non-preemptive or the cooperative That is, there is no choice in terms of scheduling. A new process may be selected for execution. Otherwise, it is preemptive. So, preemption, it is nothing but stopping the process in between. All other criteria, that is 2, 3, this goes under the preemptive. So, it may be due to consider the access to shared data, or consider the preemption while in kernel mode, or some sort of interrupt may occur during the crucial operating system activities. So if any one of the situation is there, the preemption of process takes place. Now let us discuss the dispatcher. Dispatcher, it is nothing but a module which gives control of the CPU to the process selected by the short-term scheduler. That means we switch from one process to another. It may involve, that is the context switch, then switching to user mode, or jumping to proper location in the user program in order to restart the program. So this should be as fast as possible, since it is invoked during every process switch. Thus, the time it takes for the dispatcher to stop one process and start another process. So, that particular time is nothing but we used to call it as a dispatch latency. Now, let us consider certain criteria related to scheduling. So, some of the terminology required related to scheduling criteria. The first is CPU utilization. So, to keep the CPU as busy as possible, the utilization range can be from 0 to 100%. So, in real systems, it should range from 40%, that is for a lightweight loaded systems, and 90% for the heavily loaded system. Another definition is throughput. It is nothing but the number of processes that are completed per unit time. For long processes, the rate may be one process per hour, but for short processes, it may be 10 processes per seconds. Then the turnaround time. It is nothing but the interval from the time of submission of a process to the time of completion of the process is nothing but the turnaround time. In another word, we can call it as the sum of the periods spent waiting to get into the memory, waiting in the ready queue, executing the CPU, executing onto the CPU, and doing the I. That is what we called it as a turnaround time. Then next definition is waiting time. It is nothing but the sum of the periods that spends waiting in the ready queue is the waiting time. Then the response time. So it is nothing but the time from the submission of the request until the first response is produced. So it is nothing but the time when from the submission of request until the first response. This is what we called it as the definition of response time. It is the measure of time, or it is the time takes to start responding and not the time it takes to output the response. So this is response time. So this is all about the scheduling types, that is the objectives, CPU and IO burst cycle, preemptive and non-preemptive scheduling, and the scheduling criteria. The book referee is Operating System Concept by Galvin and Gagne. Thank you.